Alright, so yesterday we talked about what?
We talked about nuclear fission and fusion.
Fission and fusion, okay? And what is the difference between chemical reactions and nuclear reactions?
Nuclear reactions have more energy.
Nuclear reactions have more energy. What else?
Whenever you chemical reaction, you get in what you get out what you put in, and then when you get less out, that's of the nuclear reaction.
Exactly. Very good. Okay, there's one more thing. There's one other difference. I'm going to go back to what Avery said, but there's one more thing. What is it? Atomically, what's the difference between a nuclear reaction and a chemical reaction? What does a nuclear reaction involve? Nuclear. TJ?
Energy?
Well, it does have energy, but what atomically does it involve? A nuclear reaction. What does it involve? The nucleus. Okay, what about a chemical reaction? What does a chemical reaction involve? Atomically, what part of the atom does a chemical reaction involve?
The whole atom.
Nope, not the whole atom.
Yeah, electrons.
Electrons, electron cloud. Okay? Alright, so let's go back to what Avery said. In a chemical reaction, what you get in, or what you put in, is what you get out. What does that mean?
If you put in, you get out the same amount that you put in.
Okay, the amount of mass that you start with is you're right, the amount of mass that you start with is the amount of mass that you end up with. Okay? And we're going to prove that today. But first of all, I've got some reactions here, and I want you to tell me whether they are chemical or nuclear. Alright? So, first reaction. Chemical or nuclear? That's a nuclear reaction?
Chemical reaction.
Chemical reaction. Okay? What's the difference? So, if it's a chemical reaction, it causes what type of change? Physical or chemical? Chemical. So how do we know this is a chemical change? Changes what?
It changes the thing. It's not the same way it was before. So
Identity. Changes the identity, right? Changes the identity. So this flame is causing the wick to go from what it was made of to ashes, right?
Yeah.
Okay, but there's also a physical change here. That candle wax goes from a solid to a liquid, right? There's also candle vapor coming off here. You can't see that, but it is. Okay? Alright, so that's one thing. Alright, so that's a chemical change. Alright, now, lights. Ooh. So what was that? How is it a chemical change?
But it changes the identity.
Because it changes the identity of the substance, right? Alright? Slice back on, please. So it changes the identity of the substance. Alright? If we look in here, what was coffee mate is now ashes. Alright? So chemical change. Alright? One more real quick. Let's do, this is calcium chloride. Alright? Alright, so calcium chloride, I'll put that in here.
Mr. Tice,
Yes, ma'am.
I just need to let Tanika Dennis know that she needs to ride the bus home.
Yes, ma'am.
Thank you.
Hey, Rob, do myself. Okay, so calcium chloride. Okay, now, and I seal this up and add some distilled water. Maybe. Okay, so now, hands up. Feel that. Now feel this. How's it feel?
Warm and cold.
Okay? So now, the amount of material, the amount of mass of water and calcium chloride didn't change. It's the same. Okay? Alright, two more. Let me get a volunteer, please. Come on up.
Wendy.
Let's go blend.
Alright, so what I need you to do, take this, and go that way with it. Okay? And then what I need you, what I tell you to, I want you to pull it real tight, okay? Let me move my trash can. Alright? So now, this is go juice. Anybody know what go juice is made of? Keep going back.
Water and go.
Close. It's juice from the go tree.
What is it? What's the one with the SMS? That's how you go juice.
Go juice. Go juice.
No.
Go. Go juice. G-O. Alright, so now, alright, give me some slack. Okay, so what I'm going to do is I'm going to put a little go juice in here. Okay, and now I'm going to vaporize it. Okay, so now I'm making a liquid into a gas. And I've got, so there's air already in here, right? So now there is go vapor from the go juice. Pour the go juice out. Okay, pull it tight. Tight as you can. That's good. Okay. So, was that a chemical reaction? Or was that a physical reaction? Chemical reaction. Okay? So, now, the amount of mass of air and go juice that was in there was the same when it was shot out. Okay? Alright, so now one more. Okay? Alright, so this is a chemical reaction as well. Alright, what I'm going to do is inside this balloon is Alka-Seltzer. Okay? So now, what I've done is I'm going to mass this Alka-Seltzer and water mixed. Alright, so it's 68.8 grams. Alright? So now I'm going to mix them. Okay? So you can tell that something's taking place, right? And if I look down here, mass doesn't change. Still the same, 68 grams. Okay? Because it is a chemical reaction. The mass before is the same as the mass after.